Hi guys, this is Mr. Krieger. We're going to do our second review on probability. This is going to be video 1 of 3. Okay, so please print up this lesson. We're going to start with tree diagrams, which are kind of essential things, especially on an AP exam. So here's what we see. A university professor fails 20% of his students on the final. After the final, he polls the students and asks how many of them studied more than 3 hours for it. Of those who passed the final, 72% said they studied for it. Of those who failed the final, 31% said they studied for it. Make a tree diagram for this problem and answer the following questions. Okay, so we're going to start by making a note here. And we're going to make a tree, and this top portion, let's call that the pass. These are the people who passed the finals. That would be 80%. And for those people who fail the final, that is going to be 20%. Then we're going to make nodes here, and these nodes are going to represent whether they studied. In this case, this will be study. And this branch is going to be 0.72. And this branch is going to be not studied. I'll just represent it by NS. And that will be 0.28. On this branch here represents study. So this is the people who failed but also studied. That's a 0.31. And these are the people who failed but didn't study. I'll put an NS there for not study. And that's going to be 0.69. You know, these are complementary 0.31 and 0.69. These are complementary 0.72 and 0.28. Now, to get the total probability of, for example, passing but studying, you multiply those values. 0.8 times 0.72, that gives you a 0.576 over here. That's the end of this line. And then pass and not study, you do 0.8 times 0.28, and that's going to be 0.224. Failing and studying is going to be 0.2 times 0.31. That's 0.062. And failing and not studying, that's going to be 0.2 times 0.69, and that's 0.138. Okay, so now we can answer these questions, which I'm going to do here so you can see it a little better. This is A. What's the probability that a student studies? Well, a student studying is going to be pass and study or fail and study. That's going to be 0.576 plus 0.062, that branch and that branch, and that's going to give us 0.638. And the probability that a student doesn't study is the complement of this, 1 minus 0.638, and that's going to be 0.362. Okay, let's try the next problem. This is a conditional probability. Let's write it this way. The probability that if a student studies, he passes. So this is pass given that he studies. Well, if you remember, it's going to be the joined passing and studying on top. Passing and studying is 0.576. And the probability of studying on the bottom, which will be that plus that, which we got over here, over 0.638. And that's going to be 0.903. Okay. D is if a student studies, he fails. So we're given that a student studies. So this is, well, we want to know that he fails. So fails, given that he studies. And that's going to be the combination of both those things. Or, you know, you could do it this way. It's the complement of this. So we could literally do 1 minus 0.9, oh, I'm sorry, I think this is a 903, not a 908. 903. So 1 minus 0.903 is 0.097. Okay, E. If he doesn't study, he fails. So what's the probability? We know the given is that he doesn't study, but he fails. So the probability is fail, given that you don't study. Okay, so that's the probability of both failing and not studying. Failing and not studying is failing and not studying 0.138 over the probability of not studying, which we have over here, 0.362. And that turns out to be 0.381. And the probability of a person's passing, given that he doesn't study, which is the complement of that. So that's going to be 1 minus 0.381, which is 0.619. Okay, so that's how we solve a problem like this, okay? Okay, let's try the next problem. This one says, it is estimated that 4% of people who spend time in the woods will get Lyme disease. Of the people with Lyme disease, the test to determine if you have it, given that a positive reading, you will give a positive reading 90% of the time. Of people who do not have Lyme disease, the same test will give a negative rating 92% of the time. Make a tree diagram for this problem and then answer the following questions. Okay, so here's what we know. Make these branches. So we know that 4% of people get Lyme disease who go into the woods. So this is a positive for Lyme, and that's 0.04, only 4% of the time. And this is, we'll just call this no Lyme disease, and that's going to be the complement of that 0.96. Now these things are going to branch off. Okay, so this branch is of the people who have Lyme disease, 97% will get a positive reading, which means that it's failing to find the Lyme disease 3% of the time. You know, you're getting a type 2 error. Let's check that. Yeah, you're not getting the reading. So this is going to be a positive test, and that's going to be 97% of the time, 0.97. That's your test comes back positive that you have Lyme disease, and then the negative is going to be 3% of the time. So there's going to be 3% that doesn't detect the person's Lyme disease. Now, if you don't have Lyme disease, you'll get a negative rating 92% of the time, which means that you'll get a positive rating 8% of the time. Basically, what we're saying here is that these people are getting a positive test that they have Lyme disease when they really don't have Lyme disease. So that's an error there. And then the negative will be the complement of that, 0.92. That's what they had given us. I'll put that, 0.92 over here. What I'm going to do is, again, I'm going to write this on a separate sheet of paper just so that we can have room to do our work. Okay, so what's the probability? Let me make sure, what's the probability that the person gets a positive reading? So you're going to do the point. Oh, actually, we didn't do this yet. We have to get these totals here, which are going to be 0.04 times 0.97 is 0.0388, and 0.04 times 0.03, which is 0.0012. 0.96 times 0.08 is, 0.08 is 0.0768. And 0.96 times times 0.92 is going to be 0.8832. These will all add up to 1. Excuse me. Okay, so now we can try these problems. What is the probability that a person gets a positive reading? There's a positive reading here, and there's a positive reading here. We're going to add the 0.0388 with the 0.0768, and that's going to give us 0.1156. What's the person that the person doesn't have a negative reading? The person gets a negative reading as the complement of this, so it's going to be 1 minus 0.1156, which is 0.8844. Okay, what's the probability that if the person gets a positive reading, he has Lyme disease? So this is the probability of having Lyme, given that they had a positive reading. So to do a conditional probability, you find the probability of the and, this and that goes in the numerator. So Lyme disease and a positive reading is 0.03, put it over here, 0.0388 over the probability of a positive reading, which we got here, because you would have to literally go that way and this way and add those two together, which we did here, 0.1156, and that turns out to be 0.3356. And D is the complement of this. It's if a person gets a positive reading but doesn't have Lyme disease. So here a person has a positive reading and does have it, and this is how it gets a positive reading and doesn't have it. So it's going to be 1 minus this value, which is going to be 0.6644. This is going to be E. Okay, if the person gets a negative reading, if a person has a negative reading, he doesn't have Lyme disease. So this is going to be the probability of not having Lyme, given that the person gets a negative reading. Okay, so we're going to have to do since it's conditional, it's the probability that both of these happen in a numerator. No Lyme and a negative is 0.8832. Over the probability of a negative reading, which will be this plus this. So which we actually have a negative reading is over here, which is 0.8844, which turns out to be 0.9986. And finally, if the person gets a negative reading, he has Lyme disease. This is the probability of having Lyme disease, given that they got a negative reading, and that's the complement of this, 1.9986, which is 0.0014. Okay, so I'm going to make a second video for the next part.